All right. Now let's discuss about the mechanics of how the central artery pulse waveforms and the peripheral artery pulse waveform happens and how they differ. All right. So now, prerequisite. I'll put some ground rules. First things first. Peripheral artery waveforms was first formed because back then they did not have a catheterization and transducers. They had a sphygmograph. It's very similar to a seismograph. Whatever bulge happens, it records as a positive deflection. Look at this here. Whatever bulge is there, the needle goes up and down. That's transmitted through a pin and it records as a positive deflection. Very similar to a seismograph. Go watch how a seismograph works. You'll understand much better, right? And one more rule is the waves can transmit whatever direction from the aorta to the periphery or the periphery to the aorta. If it forms a bulge, it is recorded as a positive deflection. That's why the reflected waves during the systole, the tidal wave is a positive deflection. During a diastole is a positive, the dichrotic wave is a positive deflection. Because percussion wave comes like this, tidal wave goes from the periphery to the reflected back. All right, done. Those are the basics. So if there's a bulge, there's a positive deflection. If there's a dip, there will be a negative deflection, right? Because if there's a dip, the needle will go down. It will go down and come up. The needle will go down and come up. All right, that's all for the basics. And other basic rule is the amplitude depends on the compliance or distensibility of the vessel. The waves take time to travel and they travel a distance. That's the second rule. And whatever waveforms we see are summations of all waves. These are rules that I created here right now to make you understand. Don't follow it blindly. The rules, as in big rules and all. Okay, fine. Now let's jump in. All right. Okay, what exactly is a compliance or distensibility? So let's say I am measuring the pressure at this point and there is blood coming in and this vessel does not want to distend. Okay, so the blood will have a force on this area. That's what actually is pressure is. But uh nowadays we use a transducer central you catheterize and record the pressure. In a stiff artery the pressure is higher, but in a compliant or distensible artery which is elastic and expands and occupies water blood is coming in, the pressure is not that high compared to here. Compared to here, the pressure is not that high here. All right, that's point number one. As we have seen, the first point is the central artery, the percussion wave. This thing right here, right? This whole thing is a percussion wave. This is a percussion wave. This is a percussion wave, right? Okay, the percussion wave in the central artery is much steeper. Sorry, much not much steeper compared to a peripheral artery. What is steep? Look at this. It's almost 90-degree. Look at this. This forms an angle, right? So first thing is it's not steep, and the amplitude. This is like 5 boxes. This is like 3 box. That's the amplitude. These are just pictorial representation. 5 box doesn't mean nothing, right? The amplitude is greater in a peripheral artery. That's what I wanted to tell. All right. Okay. Now, the percussion wave is due to LV ejection, right? Now S1 has started or LV ejection has started. S1 is different, LV ejection different. Let's stick to LV ejection. LV ejection has started. The percussion waves rising. Alright. Now in a normal peripheral artery, what comes next? After a percussion wave, your tidal wave, right? After a percussion wave, you have a tidal wave. So there is no anacrotic notch and all. But there is an anacrotic notch here. Why? What forms a tidal wave first? If you understand that, we will understand why there is an anacrotic notch. So the tidal wave is basically the reflected waves during the systole. Right? What are reflected waves in the systole are summated and they are recorded as tidal wave, right? So let's come to this picture. We are recording the central, this is the green thing is central artery waveform, and the black thing is radial artery waveform. We are measuring here. The percussion wave starts here. LV has ejected a percussion wave. It goes, and hits the periphery, right? It's the most peripheral part. Now it takes time for it to go hit first, and the wave has to travel back, right? So the LV has ejected blood and the pressure rises slowly. Then once it rises, it drops because it takes time. Now till here the pressure increases, and once it hits, it comes back. There's a time lag here. That's what forms an anacrotic notch, right? So we are measuring here. All right, the percussion wave has started. All right, now it has reached the bottom. Okay, now if it has reached the bottom, the waves would have died out, right? The waves are long gone. So when you measure here, there will be a slight dip. That's the anacrotic notch. When the waves, the reflected waves come back, they come back here. That's the tidal wave. The anacrotic notch is mainly because of the distance it has to travel, right? So the reflected waves have travel and they form the tidal wave. Now we are going to see what forms the incisura. Before explaining incisura, I will just tell one thing. Incisura or dicrotic notch are like very similar things. Incisura is like the notch, but it has become in a very short time. That's why it looks like an incisura. But a notch, it takes a lot of time to form. I will explain much clearer. Okay, now. So after tidal wave, the aortic valve closes. Very, very important, like phenomena has happened. The aortic valve has closed. Okay, so percussion wave, it has gone down, and aortic valve suddenly closed. Now what happens? Whatever column of blood that has gone down due to inertia goes back because the valve has suddenly closed. So it's almost like a sucking effect. It's like almost the valves become, like instead of bulge there is a slight dip, but actually it doesn't happen. Actually you don't measure like this in the aorta, but for explanation sake I'm telling. Okay, all right, since the blood column suddenly goes back due to inertia after the aortic valve closes, and the vessel kind of become like this, and the whatever transducer you are using, there will be a sharp down wave. There will be a very sharp decrease in pressure. That is the down wave, right? Now suddenly it will rise up, and it is followed by a dicrotic wave, right? All right. Now let's come to a peripheral artery. Now in a peripheral artery, whatever we are recording is going to be here, right? This is a radial artery. So percussion wave comes, you see a bulge, then percussion wave comes from this side, the needle experiences a bulge, it will mark the percussion wave. Alright, since the peripheral arteries are very stiff, the needle marks a large amplitude percussion wave. Done. And then see the time, the distance, it's very short. So immediately you will get a tidal wave. You won't see an anacrotic notch because the wave comes, hits, and comes back. The reflected wave is so soon, so there is no anacrotic notch. Y-axis is time. You have a reflected wave already, so you don't have anacrotic notch. and you experience a tidal wave immediately in a peripheral artery, followed by there is aortic closure, there is a column of blood. And one more thing before is here the effect of the valve closure and the blood column going up is more dramatic or more prominent compared to here. Radial artery blood column, there is not much effect of what aortic valve closes, so you don't get the incisura. Right? Aortic, the dicrotic notch here is like, okay, your aortic valve has closed, the blood column has gone up. That's happening over there. By the time the blood column reaches here, it's very damn. What I'm trying to say is like, compared to incisura, because it takes time. You get a dicrotic notch. Incisura happens in an instant. That's why it's a incisura. When it happens over time, it forms a notch. I hope you understand it, because very very confusing topic. I do get it. But that's the best way I can explain that. And similarly, your aortic valve was closed. Now whatever wave that has hit the periphery will have a reflected wave, right? That's it. That's all about the waves. I hope I was clear. Now you can see this how it is. This is the whole slide. Alright, thank you.